Hello, I'm Mrs. J, and welcome to my math class. Today we're going to cover section 11.2, which is functions or continuity with functions. Let's look at a couple graphs first. So if we look at this graph, and we want to see where it's discontinuous. If you trace with a pencil, if there's a spot where you need to lift your pencil, that's where it would be discontinuous. And notice this one has an open circle at -1. So it's discontinuous at x equals -1. So then they want us to find the limit from the left, from the right, and at that value. So we take the limit as x approaches -1 from the right, as x approaches -1 from the left. I'm going to run out of room. I hit. Okay. So the limit as x approaches -1 from the right. You could think of a dotted line coming down here. From the right, you want on the right side of the line. And our graph's here approaching ½ So it's approaching about a half. This one is from the left because of this minus sign. From the left, we go on the left side, and notice it's approaching the same spot, the 1/2. If these two are equal, this one is the same. By the definition of limits that I gave you in the last section, if these two are the same, so is this one. So if it's coming in at the same point on both sides, then this limit exists. Although at this point, there's no shaded in point, so this one does not exist. This one, you're looking for the shaded point. Let's try the next one. If we trace this, it again is discontinuous at -1. So we want to find out what happens to the limit at -1. So the break was here at -1. If we do from the right first, that means we're on this side, and our graph is up here at 1, 2, 3, 4. So the limit as x approaches -1 from the right is 4, because we're on this side of the -1, which is this graph. When we do the minus, we're on the left side, so we're here, and we're approaching 2. So think of a line coming down. This one's on the right side, the graph is here, this one's on the left. Notice they're coming into two different spots. Because of that, these two are not equal, which means this one does not exist. The last one is looking for the shaded in point, and I believe one of these is shaded in. The 2. This one is shaded in, that one's an open circle. So f of -1 is 2. We don't always have a graph to find our limits. Sometimes you have to go by the equation. When you're looking for where an equation is discontinuous, you want to look for fractions, square roots, logs. Those are places where you can't have 0. And in this case, there's no fractions, there's no square roots, there's no logs. This domain would be all real numbers. Because of that, it's never discontinuous. It's a parabola, and it's a parabola. It's continuous. Let's look at another one. If we look at this, we know in the domain we would have to omit 5 because you cannot have 0 in the denominator. So x cannot equal 5, which means it will be discontinuous at 5. So a little bit. Notice it's always the x values where it's discontinuous. Stop moving. So if we want to find the limit as x approaches 5, did it say to find? Remember, when you're finding the limit, the first thing you do is plug it in and see what happens. And if we plug it in, we have 5 squared minus 25 over 5 minus 5, which gives us 0 over 0. Well, that's indeterminate. That means we need to go back, factor, reduce, and plug it in again. So x minus 5, x plus 5 over x minus 5. Notice the common factor. That's why we got 0 over 0. So you can use that to help you factor this if you're unsure. You know that this factor is going to be up here if you got 0 over 0. These cancel. And then plug your value in again. 5 plus 5 equals 10. So the limit as x approaches 5, y will approach 10. Okay. On this one, we notice that the function is approaching our domain first. X cannot equal, this one gives us 0. And this one gives us 2. So it's discontinuous at 0 and 2. To find the limit as x approaches 0, plug it in. 5 plus 0 over 0 times 0 minus 2 is 5 over 0. We can't divide by 0, so this one does not exist. Limit as x approaches 2, plugging it in. Whoops. Oh, that's okay. 5 plus 2 over 2 times 2 minus 2 is 7 over 0. It also does not exist. Now, if we graph that function in our calculator, 5 plus x notice I'm putting parentheses. Unless you have a fraction bar, you need to have parentheses around the top and bottom. And my at the top is highlighted because I was plotting points earlier. If you won't graph, it probably could be that. Just unhighlight it, so your top should not be highlighted. My window, I'm going to make it start with negative 10, 10. So we said it was discontinuous at 0 and 2. Notice that's where these asymptotes are. Let me draw the graph over here. So the graph looks like this. If we take the limit as x approaches 0 from the right and the left, and then we'll take the limit as x approaches 2 from the right and 2 from the left. Approaches 0 from the right, here's 0. On the right, we're down here. It's going down. That's negative infinity. The limit as x approaches 0 from the left would be on this side. And this is going up, positive infinity. At the 2 from the right, we're over here, our graph again is going up. So it would be positive infinity. And 2 from the left, our graph is here going down. That one would be negative infinity. So these are all unbounded. That's why there's no limit. It's infinite. Okay, 19. If we go to graph this, we know that this is a horizontal line at 1. So at 1, it would be a horizontal line. But we only want that when x is less than 2. So if we go 2, we want it from here and everything less than it. So you think of your line, but then you only keep the part that the inequality tells you to. Like this one says from 2 to 4. So at 2, if I plug 2 in here, I get 5. So at 2, it goes up 5. Run out of room. I need 7 spots. I'm going to count by 2s. 2, 4, 6, 8. So this would be here at 1. And then this one says at 2, putting 2 in here, 2 plus 3 is 5. We're at 5. And it's equal to. And then 4, 2, 3, 4. Plugging in 4, we're at 7. And it's equal to, because it has the equal to, so it's a colored in circle. So all I did was I found the endpoints. I knew that was a straight line. And then it's 7 from anything greater than 4. Now notice 7 is the same spot. It would be an open circle, but this one colored it in. This made it continuous. So that would be your graph. Then they want to know where it's discontinuous at. Well, this one shaded in, so this is not discontinuous, but here we have a jump. So it's discontinuous at x equals 2. Well, then let's find the limit as x approaches 2 from the right. Limit as it approaches 2 from the left. So if we look from the right, we're up here at 5. Looking from the left of 2, we're here at 1. These two do not equal, so this one does not exist. From the right, we came in at 5. From the left, we came in at 1. The last one is looking in the shaded endpoint, and the shaded value would be here at 5. Try another one. Number 21. Make sure you have enough space this time. So we need 11. Okay. (11), that's a horizontal line. And we want that horizontal line for x less than -1. So x less than -1. Let's start here at 11. Everything less than. And then from -1 to 3, including, we're using this. And notice that's a parabola. And the parabola would move up too. So the parabola is here, going like this. I know it's going up because the x squared is positive. So at -1 would be at 3. And it's including the 3. I know my vertex is here because the plus 2 moves it up 2. So this is going like this. And then at 3 times, plugging it in, 3 squared is 9 plus 2 is 11. So this goes up to here, and it includes it because it's equal to. And then for x greater than 3, it's 11. And that would be your graph. Now, if you're ever unsure of a graph, remember you can use your calculator, but you should have these basic ones memorized. X squared is a parabola going up, the plus 2 moves it up 2. So it is discontinuous at -1. So we want to find the limit as x approaches -1 from the right. Limit as it approaches -1 from the left. Limit as x approaches -1, and then f of -1. Once you get used to these, you'll be able to tell, at least this one, whether it is continuous or not, or if there's an answer. Notice because these are going in at 2 different spots, these will have 2 different answers. First one is the plus, so it's from the right. -1 on the right side is here, and it's approaching 1, 2, 3. -1 from the left is on this side. It's approaching 11. Since these two are not equal, this one does not exist. Plugging in f of -1, you're looking for the shaded endpoint, which is here at 3. And that's all there is to those. 19. 35. Oh, maybe we'll start like this. The graph shows the profit from the daily production of X thousand kilograms of an industrial chemical. Use the graph to find the following limits. We want to find the limit as X approaches 6, 10, from the left, from the right, and at 10. So if we look at the limit as X approaches 6, 6 is here, it's 500. So after number of units, 6,000 kilograms, then the profit's 500. And it's in dollars. And they want the limit from the left. So if we look at 10 from the left, it's up here at 1,500. Limit as 10 approaches from the right. Go on the right side, we're here at 1,000. That means the limit as X approaches 10 does not exist because these two were not equal. Where is the function discontinuous? Well, it's discontinuous at 10, because that's where the break in the line is. What might account for such a discontinuity? Well, that's when they're switching shifts, and so nothing's being made at that time, so profit drops. Plus you have more people coming in, so then the money for them, because profit would be take out the cost. So their pay, hourly wages could be coming out, and nothing's being made, so profit drops. But then it starts increasing again. Use the graph to estimate the number of units of the chemical that must be produced before the second shift is as profitable as the first. Okay. Notice the second shift stops here, so their profit, their total profit's 1,500. For the second shift to be as profitable, it also has to hit 1,500. And that would be 15,000 units. So the second shift is not going to be as profitable as the first until it does or works 15,000 units. But then it will be profitable again. More than the first shift anyways. So some of this profit pays this group, but then they work and make it. And that is everything from 11.2.